measures of central tendency and measures of variation.
I'm going to ask her when she's
Central
done.
tendency
Strange.
or the mean, the median, and the mode. And like the description says, these are talking about what's going on in the center or around the middle of the numbers. The median is the middle. The mode appears the most often. It's usually around the middle. It's not always, but it's usually pretty close to the middle. And the mean, because it is the average of all the numbers, is usually somewhere in the middle. So these are the measures of central tendency. The other things we've looked at are the measures of variation. And on variation, we've looked at the range to see how far it was from the largest to the smallest, to see if the numbers are close together or far apart. And we looked at standard deviation. And standard deviation told us how much the numbers were deviating from the mean. Again, this told us were all of the numbers close together or were the numbers spread apart. These are the two things we've looked at so far in Chapter 2. What we're going to look at next are called measures of position. And measures of position are looking at where one particular value sits in the rest in comparison to the rest of the values. We're going to be looking at z-scores, percentiles, and quartiles. These are the numbers that tell you how one value sits in relationship to the other values. Actually, the median could be considered a measure of position because the median is the number that is in the middle. It says half the numbers are less than that particular value. So it could be considered a measure of position. But it's called central tendency because it is exactly in the middle. The first measure of position is the z-score, and the z-score is found by using a formula. And the formula for z is the individual x that you're looking for. What particular value are you interested in minus the mean divided by the standard deviation. The value you want minus the mean divided by the standard deviation. Or it can be x bar divided by s. It can work for a population or a sample. But either one, it's the value you're interested in minus the mean divided by the standard deviation. The standard deviation was how much the numbers are varying from the mean. So when you see how far this value is from the mean, in how many steps, how many standard deviations compared to the rest of the numbers, that's what z is. How far is this value away from the mean compared to the rest of the values? The z-score is used to compare two test values that have different means. Compare two values from sets with different means. If I ask, which was better? If you had a score of 395 on a test that the average is 500 and the standard deviation is 60. If this was your score 395 and the average for this test is 500 but the standard deviation is 60. Or if you took another type of test and your score was 63 and the average is 72 with the standard deviation of 4. Now it would be hard to compare these two tests. If maybe you were going to send your test results into a college, which one would you want to send that showed better how you did compared to everybody else? A score of 395 or a score of 63? Because these tests are scored so completely different, you can't can't compare a 395 to a 63. But if you find the z-value for each one, you can then compare the z-values. If I just call this the first one, and I'm going to label it z sub 1 just to keep them separately. The z from the first group. The formula says to take x minus mean over standard deviation. X is the individual score that you're looking at. Subtract the mean, divide by the standard deviation. For the second one, the score is 63, average is 72, standard deviation is 4. Now, when you go to your computer, remember anytime we have a plus or minus in a numerator, we have to put parentheses around there to tell your calculator to do the subtraction first and then to divide. So you either punch it in with parentheses, 395 minus 500, close parentheses, divide by 60. Or you can go 395 minus 500, hit an equal, and then divide by 60. But make sure you tell your calculator to do the subtraction, then divide. So 395 minus 500, close parentheses, divided by 60. The z-score is a negative 1.75. On the second one, 63 minus 72, close parentheses, divided by 4, is a negative 2.25. Now both of these scores were below the mean. If they were below the mean in negative values over here, you want the score that is better. That's going to be the score that is less below the mean. So negative 175 is the better score. This score is not as far below the mean as this one is. So this score right here, 395, on a test that has an average of 500, is the better score when you compare it to the other one. Because you're not as far away from the average on this test as you are on this test. So that's the main use of z-scores, is comparing values that come from groups with different averages. Again, it's a measure of position because it's measuring how you are ranked with somebody else, how you compare on this test compared to how you compare to everybody else on this test. The next measures of position I said we were going to look at are percentiles and quartiles. A percentile is written with a capital P, and it'll have a little number down here. P sub 20. This right here is read the 20th percentile. And if I tell you the 20th percentile is 215, that means 20% of the values are below 215. The percentiles are a little bit like the median, except the median was the middle. The middle said half of them were below that number. But the percentile says 20% of the values are below whatever that number is. Now, if 20% of the values are below that number, then that also tells you 80% are above that number. But the number that is given right here, whatever percent it is how many are below the number. Now, you can have any value there. You can have the 13th percentile, the 15th percentile. You can have any value right here on the percentile. But this is what it means. 20% of the values are below that particular number. The 50th percentile would be exactly the same thing as the median. Half of the values are below it. 50% of the values are below that. So the 50th percentile is the same as the median. The quartiles, we have two quartiles. And the quartiles are capital Q1 and capital Q3. Q1 is the first quartile. Q3 is the third quartile. Quartile comes from the same root as the word quarter. A quarter is 1/4 of a dollar. A quartile is 1/4 of the values. So the first quartile says 1/4 of the values are below whatever the first quartile is. 1/4 of the values are below that number, the first quartile. And the third quartile says 3/4 of the values are below the third quartile. So the quartiles divide your values up into fourths. You have a long list of numbers. The first quartile says 1/4 are smaller than that amount. The third quartile says 3/4 are smaller than that amount. Q2, 2/4 is the median. We don't find Q2, we don't call it the second quartile because that number has already been called the median. So we just find the first and the third quartile. We don't refer to the second quartile. That's the median. To find percentiles or quartiles, we have to go through a series of steps to figure out the percentiles or the quartiles. We'll find any percentile. You want the 20th percentile or the 30th percentile, any percentile you want. The first step is to make sure you arrange the values in order. From smallest to largest. We had to do this when we found the median. We couldn't find the middle number until the numbers were put in order. So make sure the numbers are put in order before you start looking for percentiles or quartiles. The second step to find the percentiles or the quartiles is to find a number called C. For percentiles, to find C is n times whatever percent you have. If you want the 20th percentile, it would be n times 0.2. Whatever percent you want of n. For n, like in all the numbers we've used all the formulas we've used so far, n is the total number of values. We've used n in the formula when we found the average, the mean. How many values did you have? You want to know what 20% of the total value is. Quartiles. For Q1, C is 1/4 of n. For Q3, the third quartile, C is 3/4 of n. You find that particular percent, or for a quartile, you take 1/4, 3/4 of n. You make sure the number's in order, then you find a number called C. C is not the percentile of a quartile. C tells you how far down the list to count. If 1/4 of the values is 3, you count 3 down the list. Remember on the median, when we found the median, sometimes there was exactly one number sitting in the middle. If we had an odd values, there was one number in the middle. But if we had an even number of values, we had to average two numbers. So we're going to have to do the same thing here. Sometimes the percentile will be one number. sometimes we will have to average two numbers. And it depends on what C is. If C is a whole number, if when you take a certain percent of n, or when you take 1/4 of n, you get exactly 3. It didn't turn out to be 3.1 or 3.5. If it turns out to be exactly 3, if C is a whole number, you average the value in the C position and the C plus 1 position. If C is a whole number, then you have to average two values. You average the value in the C and the C plus 1 position. Well, that didn't always make a lot of sense, so let's just look at an example here. If C turns out to be exactly 3, we're not going to take the third number, we are going to average the third and the fourth. If C is exactly 3, we will average the third and the fourth. Now, if C is not a whole number, if C turns out to be any decimal or any fraction, if C is not a whole number, you always round up to the next whole number. And round up does not mean the same thing as round off. Round off says you drop anything that's less than a 5. Round up says you always go up to the next number. You round up to the next number and take the value in that position. Now notice on this one there is no averaging. Sometimes you have to average two numbers, sometimes you pick just one value. Again, for an example here, let's say C turned out to be 7.1. If it's not a whole number, if you have any fraction or decimal, if C is 7.1, you always round up to the next whole number. Even if it's 7.00001, you go up to 8. You go up to the next number, and you would take the 8th value. There's no averaging, but you go up to the next number, and you would take the 8th value. Let's look at a list of numbers here. Notice I have already put these values in order. If they're not in order, you would have to rewrite them. You have to put them in order from the smallest to the largest. I have 27, 28, 35, 38, 39, 42, 42, 56, and 63. Let's say I wanted to find the 20th percentile. If I wanted to find the 20th percentile, I've already done the first step. I've made sure that the numbers are in order. The second step is to find C, and C says to take n times the percent. values, so count how many values I have here. I have 9 values. Times the percent, which is 20%, but we move that over and multiply times 0.2. 9 times 0.2 is 1.8. Now, if C is a fraction or a decimal, you always round up. And this just says take the second value. There's no averaging here. If you have a decimal, you round up, take the second value. The second value is 28, so P20 is 28. Now again, we always interpret things. We never stop with just saying the answer is 28. We always write a statement for that. If it's the 20th percentile, we say 20% of the values are less than 28. 20% of the values are less than 28. Now this is just a short example here. You don't usually do it in groups this small. You would do it in a group if you had 100 people and you wanted to know what the 20th percentile was. Again, you can find this for any percentile. Whatever percentile you wanted right here, you would multiply times 9 and find what value to go. Next, I want to find the quartiles. I want to find the first quartile and the third quartile for this group of numbers. Again, first step, make sure the numbers are in order. To find C, the first quartile is 1/4 times n. 1/4 of n, or 9 divided by 4, is 2.25. 2.25, again, we always round up. Even though it's just a 2.2, we always go to the next whole number. That says take the third value, so the first quartile is 35. First quartile is 35 says 1/4 of the values are less than 35. 1/4 of the values are less than 35. Remember, whatever quartile we're looking for, 1/4, it's always 1/4 or less. Now we know if 1/4 of the values are less, then 3/4 are larger. But the quartile we're given, the first quartile, is less. 1/4 of the values are less than 35. For the third quartile, again, I have to find C, and C is 3/4 times n. .75. 3/4 times n. You always go up to the next number, so you're going to use 7, and you're going to find the 7th value. The 7th value is 42. So you say 3/4 of the values are less than 42. Here, when you look at the values, all the values that are less than 42, there is another 42 in here. So to be strictly correct, you might say 3/4 of the values are 42 or less. Either way is acceptable. You can say 3/4 are less than 42, or you can say 3/4 of the values are 42 or less, because there is a 42 in this group that is less than that value. But it doesn't matter. It can be stated either way. Now, when we're talking about quartiles, there's two other values that we sometimes look at. Those values are the interquartile range and the quartile deviation. The inner quartile range and the quartile deviation. The inner quartile range, the range was just always the highest minus the lowest. So the inner quartile range is the range for the quartiles. So the inner quartile range is simply the third quartile minus the first quartile. The range for the quartiles. The quartile deviation is abbreviated capital Q, capital D, and it is the range Q3 minus Q1 divided by 2. It is half of the inner quartile range. Okay, for these that I have just found, Q1 was 35 and Q3 was 42. So if I were to find the inner quartile range, the inner quartile range is 42 minus 35 is 7. And the quartile deviation is 42 minus 35 divided by 2, or 7 divided by 2, is 3.5. Now, again, we always interpret things. If I just say the inner quartile range is 7, most people aren't going to have any idea what that means. The inner quartile range looks at the difference between this number and this number. Because 1/4 of the values were up here. And if 3/4 of the values are this way, that means the top 1/4 are this way. The inner quartile range looks at the range of these numbers if I'm not considering the lowest 1/4 or the biggest 1/4. It is the range of the middle half of the numbers. The inner quartile range is the range of the middle half. So we say the middle half of the values have a range of 7. The middle half of the values have a range of 7. Sometimes we're just interested in what's happening in the middle half. Sometimes you may have a few really, really big numbers that make a large range, but if you look at the middle half of the numbers may be very close together. So sometimes you're interested in what's happening there in the middle. What's happening to the middle half of the people? And if the middle half has a small range, then that means the ones in the middle are close together. Even if you have a few very large and very small ones to make a large range, the middle half of the numbers are close together. And that's what this is looking at. What's the middle half doing? And the quartile deviation says the middle half of the values are plus and minus 3.5 away from the median, or away from the middle. The middle half of the values fall within 3.5 on either side of the middle. That's what the quartile deviation is telling you. Again, these two values are looking at what's happening in the middle half. If sometimes you have a very large number or a very small number, we're just concentrating on what's happening there in the middle. Okay, let's look at another set of data here. values here, let's say these are the first test grade in Math 241. This is the first test grade, and I wanted to find the 30th percentile. To find the 30th percentile, you find C, and C says to take N, how many values I have. I have 10 values times 0.3. This is a percentile, so you always move your decimal 2 places. 10 times 0.3 is the number 3. Now what's different about these values is before I had a decimal. If you have a whole number, you say you have to average the third and the fourth value. So you count over here, the third and the fourth value are 78 and 82. So the 30th percentile is 78 plus 82 divided by 2. Just wanted to show you one where you have to average, because we have to remember that sometimes we have to average two numbers to get a percentile. Sometimes we just pick one value out. And it depended on what happened to C. If C is a whole number, you have to average the third and the fourth. So this says 30% of the grades are less than 80. 30th percentile says 30% of the grades are less than 80. So the next thing we want to do, besides finding a percentile or a quartile, is to find the percentile for a given value. This right here tells you something. It says 30% of the grades are less than 80. Well, if I was a teacher bragging on this class, instead of saying 30% were less than 80, I could say 70% of my class made more than 80. So you can say this in two different ways, depending on what you want to emphasize. If I want to emphasize that 70% did better than 80, that sounds pretty good. But if you wanted to take your grade, say you made a 91, and you wanted to find your percentile, how did you rank with the rest of the class? To find a percentile for a given value. To find the percentile for a given value. The percentile is equal to the number of values below the given value. How many numbers are less than the one you want? The number of values below the given value plus a 0.5. And that's just something we add on here. We just have to remember plus 0.5 divided by N. And N is always the total number of values. The number of values below the value you want, add a 0.5 divided by N. So like I said over here on this list of tests, if this was everybody in the class and you made a 91 and you want to know your percentile. The percentile then would be how many values are below 91. 7 values are below. You always add a 0.5 and divide by N. That 0.5 is just a rule you have to remember. When you divide by 10, you have 0.75, but as a percentile, you move it over, and that's 75%. So that's P75. That says 75% of the values are below 91. If you're in the 75th percentile, 75% of the values are below 91. Whenever you take a standardized test like ACT or the SATs, they usually give you your percentile. If you had a 92 percentile, that says your score was above 92% of the rest of the country. So when they give you a percentile, that's what they're telling you you have. Something called a box and whisker graph, or a box and whisker plot. Sometimes it's called a plot instead of a graph. We've looked at several different graphs before. We couldn't look at this graph until we learned some of the things like quartiles and median. On a box and whisker plot, the box and whisker plot uses 5 values. And those values are the highest value for the set of data. What's the largest number for the set of data? The third quartile, the median, the first quartile, and the lowest value. These 5 values are plotted in what's called a box and whisker. So I'm just going to make a box and whisker. It's the easiest way to show it is just to make one. At 215, 220, 223, 295, 307, 312, 317, 320, 320, 325, and 330. I want to make a box and whisker. I find all of those 5 values I mentioned. First, what is the highest value for this set of numbers? 330. Then I have to find Q3. To find Q3, we first find C. C is 3/4 of N. What is N for this set? Count the number of values. 11. So 3/4 of 11. What is 3/4 of 11? 3/4 of 11 is 825. If it's not a whole number, you always go up. You're going to take the 9th value so 320 is Q3. Third value is the median. If the median is the middle number, because there's 11 values, there's 5 above it and 5 below it, the middle value. The median, 312. The first quartile, to find the first quartile, C, is 1/4 of 11. What is 1/4 of 11? 2.75. We take the third value. And then we look for the smallest. We find the largest, the smallest, the median, and we find the 2 quartiles. Because this is called a plot, we're going to plot this on a number line. And I can see that I have to go from 215 to 330. Now I can make a number line and I can break it up anything I want to. I can go 215, 216, 217, or maybe I want to go 210, 220, 230. Well, maybe that's going to give me too many marks. Maybe I think, well, that's going to be an awful lot of marks. So maybe I want to go 200, 225, 250, 275, 300, 325, 350. You can label this any way you want to. You can count by 5s, 10s, 25s, 50. But make sure that you have the smallest number, which is 215, and the largest number. I couldn't stop here at 325 because I have a number that's 330. Make sure your number line, no matter how you label it, includes the smallest and the largest. Then what I'm going to do is I'm just going to put a mark above for each one of these numbers. The smallest number is 215. I'm just going to put a little dot up here for 215. 223. 223. 312. 320. And 330. We draw a box from the quartiles. This was the lowest and the highest. These were the quartiles. So I'm going to make a box here from quartile to quartile. That box represents the middle half of the numbers. The middle half of the numbers are from quartile 1 to quartile 3. Then we draw what is called a whisker, or just a little straight line from the box to the highest, the box to the lowest. These are called your whiskers. They are from the quartile to the lowest, the quartile to the highest. Then we draw a little dotted line here to represent the median number. This is our box and whisker. We have a box, we have two little whiskers on the end. We usually label these numbers right here so that I can tell that this one is 215, 223, 312, 320, and 330. What a box and whisker does is it allows us to look at the middle half of the numbers, and then this represents the highest 1/4, the lowest 1/4. This box and whisker says that the middle half of the numbers have a large range. The middle half of the numbers are not close. The middle half of the numbers are spread out fairly far. The whiskers tell us that there's not numbers that are a lot smaller. There's just a few smaller and a few larger. The middle half of the numbers has a large range, but there's not many larger or there's not many smaller. So by looking at this, I can say middle half of the numbers have a large range. And that's because the box is large. The box is large compared to the whole graph. There's not numbers a lot smaller or a lot larger. There's not a lot of small numbers or a lot of large numbers compared to the rest. A box and whisker can also give you a quick way of looking and seeing if a set of data is symmetrical or not. If you had a box and whisker that when you drew it looked like this. If this is your box and whisker, you can see that the middle half don't have that big of a range. The middle half are fairly close together. But from the third quartile to the largest number is a very large tail. We know that this is just 1/4 of the numbers because this right here was Q3. This is only 1/4 of the numbers, but those numbers are far apart. So if we have a tail that is longer over here, or in this case it's called a whisker, we have a whisker that is longer on the right, there are some numbers quite a bit larger than the rest. There are some values quite a bit larger than the rest. what a long tail on the right tells us. Some of the values out here were larger, even though there's not very many of them, because there's just 1/4 of them, but some of them are quite a bit larger than the rest. If there are some values larger than the rest, is this positive or negatively skewed? Positively skewed. If it's on the right, it's positively skewed. If we turn out in our box, the median turned out to be in the middle of our box, and our whiskers turned out to be the same length. If our whiskers were approximately the same length on each end, and the median was in the middle of the box, this would be a symmetrical picture. A symmetrical distribution. If there's the same amount on each side of the box, the bottom 1/4 and the top 1/4 are each the same distance away from the middle. This is a symmetrical distribution. And of course, how would this one be skewed? It would be negatively skewed. A few values are smaller than the rest. So the box and whisker is just another way to summarize data that at a quick glance you can tell whether it's positive or negatively skewed. You can tell whether the middle half of the numbers are close together or if the middle half of the numbers are far apart. So it allows you to tell what's going on with the values at a quick glance without having to look down the list of 100 numbers to see what's happening. If they're symmetrical, skewed, if the middle half of the numbers are close together, or if the middle half of the numbers are far apart, because the box represents the middle half of the numbers. Okay, let's take a break at this point.